two groups and switch their place in the molecule on one of them. Pick on one of them. Pick one of the pairs. Pick one of the pairs. Switch any two groups. Any two, it doesn't matter. You done?
I just switched one?
On one of them, switch two groups.
I don't get it.
Okay, this is the same compound. This is the same compound, right? This is the same compound because it's superimposable, right? Okay, here we go. I'm going to grab one of them. I'm going to grab only one of them. Switch one for the other. Switch one for the other. Okay, did you do that? Did you do that? Okay, here we go. Try to superimpose them now. Try to superimpose them now. Try to superimpose them now. Do that in full. Do it in full view of everybody. Everybody needs to be looking at the models. Everyone has to be looking at the models. Do it in full view. And if somebody else in the group thinks that they can superimpose them, well, give them to them and tell me, show me, superimpose them. Show me you're still holding the same one. Show me. Can you superimpose them now? What are you holding in your hand? A pair of enantiomers. You are holding a pair of non-superimposable mirror images. Now, person holding both models, please show them to me and to your group as mirror images. Please show them to me as mirror images. Can your group see them as mirror images? You see them? As mirror images. Is that okay? Okay. Let me have this pair right here. Hold that one. This is a mirror. This has a mirror image because the only requirement to have a mirror image is to have what? A mirror. Because unless you're a vampire, everything has a mirror image. I don't want you to walk away from these lectures thinking, oh yeah, they're enantiomers because they're mirror images. No. Everything has a mirror image. It's what you can do with that mirror image that makes a difference. When I put this in front of this mirror, what do I see in there? What do I see in here? It's an enantiomer. If I were able to stick my hand inside of that mirror like in the Matrix and pull out the mirror image, I would be holding this. And I can hold them and say to myself, yeah, definitely, these two things are mirror images. Let's take it a step further. It's what you can't do with a mirror image that makes these two enantiomers. What is it that you can't do with these? Match them point for point, because every time you try, you'll realize two of them are in the wrong place. Is that okay? Here's a mirror. Here's a fork. The fork has a mirror image. Damn, I gotta do my hair. What do you see inside of that mirror?
Fork.
The mirror image of this fork, right? Which I happen to have right here. Is that the mirror image of the fork?
Yeah.
This fork is not like the molecules you have, because I can take this fork and superimpose it point for point. This fork has a plane of symmetry, because it has a plane of symmetry running right through the middle. That allows me to superimpose it on its own mirror image. Anytime that you find that an object has a plane of symmetry, you will be able to superimpose it on its mirror image. This is the same item. They are not two different forks. They are the same fork. Same thing happens with a spoon. The spoon also has a mirror image that is superimposable. I can take it out of the mirror in any direction you want me to hold them. It doesn't matter. I can take it out of the mirror and put it point for point. This is the same item. Enantiomers are not special, and they're not enantiomers because they're mirror images. It's because they possess the property of chirality, of not being able to be superimposable on their mirror images, like my right and my left hand.
God bless you.
This, watch my hands, this is not superimposing. Don't tell yourself, oh look, it's the same item, I superimposed them. What am I holding? Mirror images. What's superimposing? That would be this. Point for point, direction for direction. I can never superimpose my right hand on my left hand. Is that